I have this unit review to go over, and some of the questions are just kind of, they're kind of tough.
Okay. Let's have them.
So the first one is, okay. Hold on, sorry. Okay. So it's sketch a graph of a parabola labeling the focus, axis of symmetry, and directrix for x squared equals 1/16 y.
Okay. Is that a vertical or a horizontal parabola?
I think vertical.
Yeah, and the way to remember it is the one you learned before they got to conic sections was this, right? In other words, you've been working with this quadratic for quite some time. And as long as it's y equal x squared, well, that's a vertical one. If it's y equal minus x squared, then it points down, but it's vertical nonetheless. Okay? So the other possibilities you can have are horizontals. Well, you get a horizontal parabola when you get x equal y squared. Then that's the one that looks like this. Or if you had x equal minus y squared, it would open to the left. Do you still hear me, Anna?
Hey, can you hear me?
I can. Can you hear me?
Yes.
Okay, cool. I'm not sure how much of what I said you heard.
Yeah, I didn't hear anything.
Okay, well, let's start from scratch again. You basically have two kinds of parabolas. Y equal x squared, which is the one you've been learning for a couple of years.
Yep.
All the way back to Algebra 1, you learned y equal x squared was a parabola.
Right.
The reverse of that is x equal y squared. Well, if I have x equal y squared, that's got to be horizontal. In other words, it's got to look like that or it's got to look like that.
Okay.
So that's how you immediately tell the difference between vertical and horizontal. Now, what have they taught you? Let me see if I can write. See if this matches what they've taught you is the general format. Does that look familiar? Is that what's in your book?
No, she has, remember, x squared equals 4cy.
Okay, well, that's the same as this.
Okay.
Okay, this is no matter where the vertex is. In other words, the one you just gave me, 4cy equals x squared, that's the same as this, only k and h are 0.
Okay.
Okay? And the fact they're using a c instead of a p doesn't really matter. C is the distance from the vertex to the focus.
Okay.
Okay? But they did teach you this one down here at the bottom, right?
Yes.
Okay, because some school systems still use the vertex format. In other words, they use this one. Remember, this here is the vertex format, and
Right.
then they tell you that A is 1 over 4C. And so they just stick with this format here and let you solve for A and then solve for C. I actually prefer using this format here, and this is the more complicated form of that same format, only when the vertex is not at the origin. Well, in this particular problem, the vertex is at the origin. In other words, there's no number that's being added or subtracted to x, and there's no number that's being added or subtracted to the y. So let's erase this and use this format here. So what is C equal to?
Is it 1/16?
No, that would 4C would be 1/16. In other words, I definitely can say that 4C equals 1/16, right?
Oh, so
Because
I have to divide.
what we're looking at with 4C is the coefficient of y.
Okay.
And then you divide both sides by 4 and you get 1/64. So that's what C is.
Okay.
Now, let's talk about the things they asked for. First of all, we know this is a parabola with, well, it's flatter than a typical parabola, right?
Right.
In other words, it's going to look something like this, because 1/16 is less than 1. And now the focus is always inside the parabola by some distance, and that distance is 1/64. So the coordinates is 0, 1/64 of the focus.
And that's the focus?
That's the focus. Now,
Okay.
what's the axis of symmetry?
Well, do I have to find the vertex to know that?
Well, you can see where the vertex is. The vertex is at the origin. And the axis
So,
of symmetry always runs, in other words, it means exactly what it says. After you draw it, your parabola is going to be symmetrical about that line.
okay.
If you draw it in any other manner that doesn't produce symmetry, then you haven't put it in the right place. What's the equation of that line?
X equals 0?
Yeah. Oddly enough, x equals 0 is the y-axis. It's the equation for the y-axis. Just like y equals 0 is the equation for the x-axis. Now the last thing we need is this directrix. Okay? And the directrix is the same distance from the vertex as the focus is. So what's the equation of the directrix line?
I don't really remember that one.
Well, if you look at it, and I said it was the same distance from the vertex as the focus, so how far down from the vertex do I have to go?
Negative 1/64?
That's the equation of that line. Y equal negative 1/64. In other words, horizontal lines are always y equals some number. Vertical lines are always x equals some number.
Okay.
Okay? So this actually was relatively straightforward. We just had to set that coefficient equal to 4c.
Okay.
Okay? All right. What else do you got?
It says graph the linear equality and shade the solution area.
Okay.
And negative 3y is less than x plus 12.
Less than x what?
Plus 12.
Okay. What we basically are going to do is graph this like it was a linear, a straight line. And then
Okay.
figure out whether it should be a dotted line or a solid line. And then
Okay.
figure out which side of that line we're going to draw. Well, to graph a straight line, the best way to do it is to get it into y equals mx plus b format.
Right.
Well, what do I have to do to get it into that approximately?
Well, you're going to have to divide by negative 3, right?
Correct. Okay. So I'm going to divide both sides by minus 3. And when I do that, what do I do with the inequality sign?
I'd flip it.
Flip it because I'm dividing by a negative number. If you divide or multiply an inequality by a negative number, you have to flip the sign.
Okay.
Okay? And now that gives me y is greater than minus 1/3 x minus 4. Make sure you see how I converted that to this.
Right.
Okay?
Okay.
Now I can graph that as a straight line. Is it going to be a dotted line or a solid line?
It's going to be a dotted line.
Correct. If it's strictly this, it's dotted. If it's greater than or equal, it's solid.
Okay.
Okay, where do I start?
Negative 4.
Okay. What next?
And then I think I go,
Sorry, what?
or I go down 1 and then to the right 3.
Okay, cool. So if I go down 1 and to the right 3, puts it pretty close to there. And it's a dotted line that I'm going to connect those 2 points with. Which side do I shade looking at this picture?
So y is greater.
When you're trying to figure out which side to shade, always look to the y-axis, not the x-axis.
Okay.
So your answer should always be above or below, never right or left.
Okay.
Okay, so what should it be, above or below this?
Above, I think.
Yeah, because y has to be greater than that. So all I have to do is go to the y-axis and find any point at all on the y-axis that's greater than that line. Well, I could pick a point up there. Now that tells me which side to shade. Okay?
Okay.
Now, the reason I said always say right or up or down is if I have something that looks like this, and let's say my equation is y is greater than 50x, negative 50x, excuse me. Which side would I shade?
You shade to the left.
Remember I said never say left or right. Always say up or down.
Right, so it would be up.
Which is actually to the right. In other words, it's this side over here that I'm shading.
Okay.
Okay? But I determined that by looking at the y-axis, always look at the y-axis only, finding a point that's above the line, that tells me which side to shade.
Okay.
And it is the right side, but you shouldn't think of it as being the right side. You should think of it as being above the line.
Okay.
Okay, and if it was less than, it would be, I would pick a point on the y-axis there, and I would shade that side. All right?
Okay.
All right, let's do another one and let you do it,
Okay.
if you have one similar.
No, these are all just like, they're different questions.
That's okay. All right, we'll go through them. Oh,
So this one says solve the system using any method, and it's 7x minus 4y equals 13. And then the other one is 8x plus 2y equals 5.
okay, these equations, which are both equations of a line, are given to you in standard format, not in y equal mx plus b format.
Okay.
Okay? And when you're given the two equations in standard format, and standard being the x and the y are on the left side of the equation and only a number is on the right side, the easiest way to always solve these, I'm convinced, is by elimination.
Okay.
You basically know two methods, substitution and elimination. Okay? The key with elimination is you want to be able to eliminate a variable. Now, you always can add or subtract any equations. So it's proper, if I want to, I can add those two equations. I just add the x terms, I add the y terms, and I add the numbers. If I do that, I don't eliminate anything. I get 15x minus 2y equals 18. So that doesn't help. But remember what else you can always do to equations. If that's equation 1 and that's equation 2, I can always take any equation and multiply one side by a number as long as I multiply the other side by it.
Okay.
Okay. So what should I multiply equation 2 by?
By -2.
Let's do it by positive 2, and I'll show you why.
Oh, right, because gotta, okay.
You want to be able to add the two equations, only because addition is always safer than subtraction. Okay, so first of all, let's rewrite equation 2. Remember, I have to multiply every term by 2. Let's draw a line through that so it doesn't confuse us. Now we have two equations, and if I add them together, a variable gets eliminated. So what would I have?
So the y's would be eliminated.
Right.
The 23x equals 23.
So x equals 1, but we're not done yet. We have to go back and solve for y. How do we solve for y?
You plug in x to an equation.
Yeah, which one? Which equation should I plug it into?
I'd just do the first one.
Okay, that's fine. So now I got 7 times 1 minus 4y equals 13. What next?
So you subtract 7.
Okay, now I got minus 4y equals 6.
And then you divide by -4.
So now we got y equals minus 3/2. In other words, you get minus 6/4, but you can simplify that to minus 3/2.
Right.
Okay? Now, let me just say a word about that. When you're trying to figure out which equation to use, don't use the modified number 2 ever. If I asked you now, what's the best way to solve for y, which one would you use?
Probably equation 2.
Yeah, because everything's positive. I don't have to deal with that negative sign like we had to. In other words, when I used equation 1, I ended up with this minus 4y here. Well, if you ever have a choice between using positive coefficients or negative on the variable you're trying to solve for, always use the positive coefficients. Notice that this comes in as 8 plus 2y equals 5. So 2y equals minus 3. Y equals minus 3/2. Get the same answer, but not as much likelihood to make a mistake, I don't think. That's just kind of a rule I use, is that I'm always going to choose the one where the numbers are small, 5 smaller than 13, and the coefficients on the variable I'm trying to solve for, y, is positive. Okay, and it's always going to be better to use the original equation rather than the modified one, because the modified one is twice as big. So everything's twice as big. We'd have 16 times x plus 4 times y equals 10. So smaller numbers are always better. Positive coefficients are always better. Now, let me say one other thing about this problem. When do you use substitution to solve? What's a good rule?
Probably when you can't multiply any of the equations to cancel out a variance.
Well, usually if they're not in standard format, then in other words, let's say that I made equation 2. Let's see, that's 2y. So I got y is going to be minus 8x plus 5 divided by 2, right? In other words, that's equation 2.
Okay.
So all I did is solve for y. You with me?
Yep.
Okay. Now, if they gave me these two equations, let me erase that one. Now, it wouldn't be so easy to solve by elimination. I'm going to have a terrible time eliminating it because they're not in standard format, but I can substitute pretty easily for it. In other words, I'm going to go up to equation 1, and wherever I see a y, I'm going to substitute what I have right there.
Negative. Okay.
And that will then give me 7x minus 4 times this whole thing. But notice I can solve for x. I've got one equation and only one variable, x. I mean, I got quite a bit of math to do to solve for it, but the fact is I can do it. In other words, so the rule I kind of use is that if you have one equation that's fully solved for one of the variables, like this equation 2, then substitution is your best plan.
Okay.
If they're both in standard format, then elimination is the best plan. Now, there's one other case. Let's say I have y equals that, and y equals... Now, how do I solve that?
Well, I would just
First of all, would I do substitution or elimination?
elimination.
Not really. It's not in standard format. Although I can see why you said that. And elimination is not a bad way to go here. I just realized that. But that's not typically how you solve it. When both equations are defined for y, then what you do is you let that
Equal to each other.
that.
Okay.
So if I tell you y equals a, and at the same time y equals b, well, you know that a has to equal b, right?
Yeah.
So, and once I do that with this, it becomes very easy to solve, which is 3x minus 4 has to equal 2x plus 5. I'm going to bring the x's on the left, the numbers on the right, and there's my solution. Very quick. Now, you did pick up on something that I had never realized before, and that's that actually you can solve these by elimination pretty quickly by just subtracting, huh?
Yeah.
Even though it's not in standard format, if I subtract the two equations, I get 0 over there equals x minus 9. Move the 9 over, and you got your solution. So elimination's not a bad way to go there. I've just never used it. But it actually works rather nice. Whenever you can use elimination and eliminate a variable, it's not a bad way to go.
Okay.
Now, let me just give you another couple pointers. Here you have two equations, system of equations, and they're in standard format. So I'm going to try to solve them by elimination. Notice that substitution isn't so easy because I would have to solve one of the equations before I'd be able to substitute anything.
Right.
But elimination, I can go immediately. But notice that I can neither add them or subtract them and have a variable disappear. So what to do?
I'd change one of the equations and set it equal to y.
Okay, there's a different method. Let's try solving this by elimination.
Oh, okay.
What the method you just stated would be solving for y, and then we're going to use substitution, which you can certainly do, but try to embrace elimination when you're given the equations in standard format. It's just almost always going to be easier. Okay? Now, I gave you a particularly tough one. I could multiply equation 1 by 1.5, right?
Right.
In other words, I could multiply that by 1.5 and that by 1.5, and I'm going to produce a 3y. Then I'll be able to add them and eliminate y. Okay? What I don't like about that is that I introduce fractions, because now I got 4.5x and I got 15 over there, but I don't want to introduce fractions at all. So I'm not going to do that.
Okay.
What I am going to do is I'm going to multiply the top equation by 3 and the bottom equation by 2.
Okay.
Notice now what I have. Equation 1 becomes 9x plus 6y equals 30. And equation 2 becomes 4x minus 6y equals 10. Now that's beautiful because now I can add the two equations and come up with my answer.
Right.
13x equals 40. X equals 40 divided by 13. I made these up off the top of my head, so you're not going to necessarily get integer answers. But this is an excellent illustration of when you have to multiply both equations by some number.
Okay.
Okay? And Okay, what next do you have? I'll let you give it.
Let's see. Okay, it says graph the equation y equals 2x squared plus 4x minus 3. You to label at least 5 points, including the vertex, and I have to identify domain.
Okay, what's the rest of it? 2x squared plus 4x, what?
Minus 3.
Minus 3?
Yes.
Okay. First of all, for us to get all of that information, we need to factor this, probably. We need to try to factor.
Okay.
Okay, if I can factor it, then I will kind of have it in x-intercept format. In other words, the other equations, you have a couple of formats for quadratics. You have this one. This is the most standard one. This is Vertex Format, where H and K are the vertex. You also have this one, which is X-intercept format, where P and Q are the x-intercepts. We don't know the vertex, but we know the x-intercepts. And then also there's the standard one, which is y equal ax squared plus bx plus c. And this is the one, if you have it in standard format, let's see, this is vertex format, this is x-intercept format, and this is in standard format. And if you have it in standard format, you can always use the quadratic formula on it.
Right.
So each of these formats has its own uses. What they want is for us to be able to graph the parabola, 5 points, is that what you said?
Yes.
Determine the x and y intercepts, the vertex, and the domain. Was that everything?
Yeah, we don't have to identify the x and y. Oh, wait. Yeah, we don't have to identify the x and y intercepts, or the x-intercepts.
Okay. We just need 5 points.
Yep.
Okay. Well, let's try to factor this, because if it's factorable, then it's going to look like the x-intercept format, and we'll have our x-intercepts, which are 2 points, and then we'll actually be able to get the vertex also. So let's start with 2x and x. The signs have to be opposite, either plus minus or minus plus. Not very many factors of 3. I can tell it's either 3 and 1 or 1 and 3, right?
Right.
3 and 1 does not produce a 4x in the middle. 1 and 3 does not produce a 4x in the middle. Let's make sure that you know why that's true here. Let me erase the vertex format just a second. In other words, when I'm factoring these more difficult quadratics to factor, the key is, can I produce the middle term of 4x? Well, the middle term always comes from the inside terms multiplied together added to the outside terms multiplied together. Well, that's 3x, that's minus x, that, or minus 2x, that would produce a middle term of x. Okay? With me?
Yes.
I try the 1 there and the 3 there. Well, that produces a middle term of plus x minus 6x. That would be minus 5x. That's not the correct middle term either. And I know from having done this many times that it doesn't do any good to just drop these numbers down to the opposite signs. I'm still going to produce the same middle term. In other words, I cannot produce the middle term by factoring this.
Okay.
Okay, so we have to figure out another method. One method that I'm particularly fond of is the vertex, the x-coordinate of the vertex is equal, we've got this thing in standard format, right?
Yes.
What's the x-coordinate of the vertex equal to when it's in standard format?
The x-coordinate of the vertex?
Yeah, it's minus b over 2a.
Oh, okay.
Notice what the quadratic formula is. Minus b plus or minus b squared minus 4ac all over 2a. Well, it's the first half of the quadratic.
Right.
So that's a way to remember it. In other words, if you know the quadratic, then you know how to solve for the x-coordinate of the vertex. If you know the x-coordinate of the vertex, then it helps you remember the quadratic. So they kind of go a little bit hand in hand. You want to have both of these memorized. Okay? I don't know how she gives her quizzes, whether she lets you take a sheet of formulas in there or not.
Yeah, we get to.
Oh, you do get to? Okay. Well, let's use minus b over 2a. What is the vertex? What is the x-coordinate of the vertex using minus b over 2a?
It ends up being 1, I think.
Yeah, minus 4 over 4. So actually, it's minus. Now, how do you get the y-coordinate of the vertex?
Well, you plug in -1 for x.
Correct. So we got 2 times minus 1 squared plus 4 times minus 1 minus 3. What's all that equal to? What y?
Let's see. So 2 times -1.
Hold on. Got to square the -1 first.
Oh, I have to square that first?
Yeah, the PEMDAS.
Oh, right.
Parentheses, exponents, multiplication, division, addition, subtraction. That's always the order you have to go in.
Okay, well then they'll just end up being 1.
Yeah, the reason is that this 2 is only operating on the -1. It's not operating on this other 2.
Right.
So I cannot distribute that first 2 and then square it. I got to square it first and then distribute it. And it does make a difference here, because when we square -1, it turns into +1.
Okay.
So you got 2 minus 4 minus 3. That looks like -5. So that's the y-coordinate of the vertex.
Okay.
Let me erase some of this so I can start to graph it. So the very first thing I'm going to do is go to the x and the y coordinates. -1, -5, right there. Okay? We know that's the base. Well, I got to come up with 5 points. What's a real easy other point to come up with? In other words, that's also the line of symmetry.
Oh,
the line of symmetry always runs through the x-coordinate.
Okay, so it'll be x equals -1 for...
Well, no, the vertex is a point. So the vertex is -1, -5.
No, I'm talking about the axis of symmetry.
Ah, yes, sorry. Yes, x equal -1 is the equation of that line.
Okay.
Okay. Now, it turns out that the next easiest point to plot is the y-intercept. And the reason is, if you look at the function, erase this. What's true about x when we're talking y-intercept?
like I mean, I don't know.
When you're talking y-intercept, x is 0, correct?
Yeah.
And when you're talking x-intercept, y is 0.
Okay.
Those are two things to always remember. Whenever they're talking intercepts, make the other variable 0. Well,
Okay.
if I make x 0, then that's always my y-intercept. So I don't even have to do any math. That number is my y-intercept at -3 right there. 0, comma, -3. Now that, because of symmetry, in other words, now I know the thing does something like that, and it has to do the same thing on the other side because that's an axis of symmetry. So can you figure out what that point right there is?
That'll be -2, -3.
Okay, good. There's 3 points. She wanted 5, right?
Yep.
Well, I could plug in numbers for x if you want.
Okay.
In other words, I could plug in a 2 for x and see what y is.
Yeah, that would.
Well, I don't know that that's the best way to go. Gosh, actually, it might. In other words, typically she would want the x-intercepts. She would want those 2 points. Whenever you're talking parabolas, you want the vertex and you want the x-intercepts, almost always. You don't need 5 points to define a parabola. 3 points do it. In other words, if I had just the 3 points that I have already, that's all I need. Everything else is predetermined. There's no way any more points shed any more light on the problem. 3 points define a parabola. But for the sake of argument, let's solve for these x-intercepts. So because I'm solving for x-intercepts, I'm going to let y equal 0.
Oh, okay.
Okay. Now, if I can solve this equation, I'll have my 2 x-intercepts.
Right.
Well, I already know I can't factor it.
So
I'm going to have to use the quadratic formula on it.
Okay.
So x is going to equal what?
X is going to equal -4 plus or minus the square root of 4 squared minus 4 times 2 times -3 over 2 times 2.
There we go. Okay. Now, when you're solving using the quadratic formula, always be a little careful here. When you're trying to figure out what this discriminant is, the discriminant being the part inside the radical sign, you're generally looking at a lot of negative signs. That one's always there, and that one's usually negative. C is. And it's real easy to make a mistake here. What I normally tell everybody to do is multiply the 4, the A, and the C together, come up with a number, and then subtract that from 16. So 4 times 2 is 8. 8 times -3 is 24. So these 3 numbers, not counting that subtraction sign, these 3 numbers turn in to -24. Let me just, because I'm kind of out of room here. -24. I'm going to leave it in parentheses because you got to be very careful here not to drop a negative sign. Now, -4 plus or minus the square root of 40 all over 4. Can I simplify that any? Can you simplify root 40?
Yeah, you can, but it'd be like, there'd be a number on the outside of it.
That's what we want. In other words, when we're simplifying radicals, the only time it ever makes sense to simplify it is if you can pull a solid number out. Well, the first step is to factor it, where one of your factors is a perfect square number, like 4. Remember what your perfect square numbers are: 4, 9, 16, 25. So you're always looking for factors, one of which is one of those numbers, or 36, or 49. You with me?
Yep.
Okay. And this turns into 2 root 10.
Okay.
Okay, so I've pulled my number out. That makes this simplified over that. Now, I cannot simplify root 10 anymore. Root 10 could be written as root 2 times root 5, but neither of those are perfect square numbers.
Right.
So you wouldn't do that. You'd leave it as 2 root 10. Now if I go back up here and I substitute 2 root 10 instead of root 40, now can I simplify it further?
Yes.
What can I do?
Well, you could divide everything by 2.
Okay, minus 2 plus or minus, that becomes 1, so I just have the root 10, and then all over 4. There are my two answers. Minus 1/2 plus root 10 over 4. Oops, excuse me, this becomes a 2, doesn't it?
Mm-hmm.
Yeah, sorry. Minus 1. Or minus 1 minus root 10 over 2. There are your two x-intercepts. And that's exactly the way you want to write them. In other words, if I go up to my graph, this intercept on the right there is minus 1 plus root 10 over 2, comma, 0, the y-coordinate.
Okay.
The one on the left is what?
Minus 1 minus square root 10 over 2.
And you have to put the y-coordinate on there also. In other words, it's confusing to see this answer.
Yeah.
Okay, that doesn't look like a typical answer. But it's the only way to accurately show that number. I could convert it to decimal points, but then I'm rounding it off. And typically they don't want you to do that anymore once you get to Algebra 2.
Right.
They want the answer written like this. But if you write it like this, make sure you put the y-coordinate in there. In other words,
Okay.
that's the x-coordinate only. So now we have our 5 points.
Mm-hmm.
And what else did they want?
They wanted domain and range.
All right. So we can look at the graph to get both of those. On parabolas, the domain is always what?
Negative infinity to infinity.
Correct. No different here. The range is what here?
I think it's going to be negative 5 to infinity.
Correct. And is there a bracket or a parenthesis?
It's a bracket around negative 5 and then parentheses.
So if you're doing interval notation, that's what the range would be.
Okay.
If you're defining it like this, then it's greater than or equal to negative 5. That means the same thing.
Okay.
It just depends on whether you're into interval notation yet. I don't know if you are or not.
Okay.
So I think that's it, right? We did everything for this problem?
Yeah, I think so.
Now there's a lot of ways to go here. I didn't choose the only way. I chose what I thought to be the easier way, which is to find the vertex using minus b over 2a. And that'll give you the x and the y coordinate. for the vertex? Well, the minus b over 2a only gives you the x coordinate, but then you plug in the answer to get the y coordinate.
Okay.
And then solving for all the other points, solving for the y-intercept was really easy. Solving for the point on the other side was really easy because it's symmetrical.
Mm-hmm.
The only tough part was solving for the x-intercepts.
Yeah.
Well, she didn't actually say she needed the x-intercepts.
That's true. Yeah, I was just gonna. What she usually has us do is like just plug in a number.
Right. In other words, I could have plugged in x equal 1.
Yeah.
Okay. Well, that's right there, approximately. That's an x of about 1. Well, and then the y would be 2 plus 6 minus 3. So when x equal 1, y equals 3. And that's 1 point. And then I also know that it's got to be symmetrical about that point. So this would have to be minus 1 and 3. I haven't graphed them on the correct side of the x-axis, but you get what we're doing.
Yeah.
And actually that is quite a bit easier. In other words, anytime you can avoid using the quadratic formula and having answers like we got, you're better off. And so just plugging in whole numbers is a lot easier. And then you can always find the other side that's symmetrical to it, right?
Right, yeah.
In other words, that point that I plugged in, 1, is 2 units away from my line of symmetry. So I would have to go, I labeled this one wrong. The x-coordinate would be minus 3, comma 3. That would be that point right there. Okay?
Okay.
In other words, you use the same strategy you used once we found the y-intercept to find the other symmetrical side of it.
Okay.
Well, you can use that same strategy when you plug in a point for x. Now,
All right.
I don't get the x-intercepts, but I got 5 points, and if she doesn't really care whether they're the x-intercept or not, it's much easier to plug in a number for x and do it this last way. And there's also completing the square. I could have begun this whole problem by completing the square on the formula and putting it into vertex format, in which case I'd know the vertex instantly without going through this minus b over 2a.
Okay.
And then I go from there. In other words, the name of the game is to find the vertex, first of all.
Right.
And this is a pretty easy way of finding it. Whereas completing the square, if you're not up on your completing the square, that can be a little intimidating. But it's the other way to go. The advantage of completing the square is you end up with it in vertex format, and then you can just read the vertex. In other words, vertex format being this, y equal a times x minus h squared plus k. Well, once I get it in vertex format, I'm staring at h and k, which is the vertex.
Okay.
Okay? You still have to use these other techniques for finding the other 4 points, but for getting the vertex, you can either complete the square, put it in vertex format, or you can use the minus b over 2a if the thing is in standard format.
Okay.
Okay? Now, do you have any problems on there that call for completing the square?
I don't think so, unless you have to, there's a lot of like changing right an equation in factored form and write an equation in vertex form.
Okay, let's do that on this equation.
Okay.
We got 5 minutes. Let's complete the square and put it in vertex format.
Okay.
You said you have some problems where they want you to put it in vertex format, right?
Right.
All right. Hold on.
I have a whole nother equation it asked me to write in vertex form.
Okay, let's do that one.
Okay.
Go ahead and read it to me.
It's 3x squared minus 6x equals 6 or parentheses 2x plus 8.
3x squared minus 6x equals what?
6 parentheses 2x plus 8.
Okay. Vertex format is this. So we have to take this equation we're looking at and make it look like this over here. Well, first thing to really do is to get all your x's on one side. In fact, get everything on one side. You'll notice in this equation over here, everything's on the right side.
Right.
Okay. So first of all, let's distribute that and then get everything on one side. So
Okay.
when I distribute that, I get 12x plus 48. Now we're going to move everything over to the left, so I get 3x squared minus 18x plus 48
Okay.
equals 0. That's a very important part of it. Or equals y. It's actually equal to y, not 0 yet. Okay? Now, I can make this look like this by completing the square with this part of it right there. Do you remember how to complete the square?
Yes, it's negative b over 2a. Oh, no,
Not quite. The very first thing I need to do is make sure this coefficient is 1. So I have to factor out a 3 from these two terms only. And I'm going to do that like this. And then I'm going to leave a little space to write more in. Notice that I have not changed the equation one bit. This equation's the same as what I started with.
Okay.
All I'm doing is manipulating it with each step, trying to get closer and closer to the vertex format. Well, you can see I'm not that far from it now. Now
Right.
I can complete the square, and you were correct. I take the coefficient of the x term, divide it by 2, and square it. What's that?
So, of the x term?
The coefficient of the x term, divide it by 2 and square it.
Okay. So, wait, the x term is 6, right?
Right.
Negative. So, it would be 6 over 2. So, it would be 9.
Take half of 6, which is 3, square it. So now I'm going to write a 9 there.
Okay.
Well, how much did I just add to the equation when I wrote a 9?
27.
So I got to subtract 27 from the same side. Now it's exactly the same as what I started with.
Okay.
Okay? In other words, as long as I'm balancing on the same side of the equation, I got to do the opposite of what I started with. Well, the fact that I completed the square now allows me to write this as a x minus 3 quantity squared. Combine those two numbers and you get plus 21.
Well, where did the 9 go?
Is all I did was I added, when I wrote in plus 9, I added 27 to the left side of this whole equation. So by subtracting 27, I canceled out the effect of writing that 9 in there.
Oh.
In other words, my goal is to manipulate this top equation so that it looks exactly like vertex format, but I don't ever want to change it. I don't want to add numbers to one side or the other without adding them to both sides or balancing them out on one side.
Okay. Well, what about...
By the time I get down to that last step, it's exactly the same as that original equation. The thing is, it's in vertex format now.
Okay, did you just divide negative 6 by 2?
Yeah. In fact, I don't even divide negative 6 by 2. I just took half of 6.
Okay. Do you do that every time?
When I squared it, it's always plus here. Because whether it's negative or positive, when you square it, it becomes a plus.
Okay.
Okay? But now I can now write this quadratic that's in parentheses as a linear term squared. Always. You can always do that when you've completed the square. That's why we complete the square, is so that we can write this as a linear term, x minus 3 squared. And now we've got everything. H is 3. In other words, the x-coordinate of the vertex is 3. The y-coordinate is 21. And A, the vertical stretch factor, is 3. Not that I need the vertical stretch factor. In other words, if I'm going to plot this, I'm just going to start with the vertex and go from there. But that's the advantage of taking an equation and putting it into vertex format, is that you can immediately plot the most important part on the parabola, which is the vertex.
Okay.
Okay?
All right.
All right, let's see. Is your brother going to do the 5:30 appointment today? Do you know?
Yeah, I think he is. If he doesn't want it, then I'll probably do another session with you.
Okay, I will text him a meeting ID number in 30 minutes.
Okay, sounds good.
All right, Anna. Bye-bye.
All right, bye.